हेलो व्यूअर्स, वेलकम टू माय चैनल एंड थैंक यू फॉर वाचिंग द वीडियोस। इस वीडियो में हम होमोजीनियस लीनियर पार्शियल डिफरेंशियल इक्वेशन विद कांस्टेंट कोफिशिएंट से स्टार्ट कर रहे हैं। तो जैसे कि हम ऑलरेडी जानते हैं पार्शियल डिफरेंशियल इक्वेशन, लेकिन फिर से डिफाइन करते हैं लीनियर पार्शियल डिफरेंशियल इक्वेशन को। ए पार्शियल डिफरेंशियल इक्वेशन जिसमें कि डिपेंडेंट वेरिएबल और उसके जो डेरिवेटिव्स हैं वो अपीयर होते हैं इन फर्स्ट डिग्री ओनली। ऑर्डर कुछ भी हो सकता है बट डिग्री फर्स्ट है, एंड दे आर नॉट मल्टीप्लाइड टुगेदर, क्योंकि अगर मल्टीप्लाइड टुगेदर होंगे देन ऑल्सो डिग्री विल बी हायर देन 1, एंड देयर कोफिशिएंट्स जो हैं कांस्टेंट होते हैं या फंक्शंस ऑफ एक्स एंड वाई होते हैं, तो वो लीनियर पार्शियल डिफरेंशियल इक्वेशन कहलाती है। ए लीनियर partial differential equation is a partial differential equation in which dependent variable and its derivatives appear only in first degree, order may be any, and are not multiplied together, their coefficients being constants or functions of x and y as a linear PDE। डिग्री मोर देन 1 है या मल्टीप्लाइड है वो नॉन लीनियर हो जाएंगे, एंड अगर डिग्री 1 है एंड आर नॉट मल्टीप्लाइड अलोंग विद ऑर्डर इज सेम ऑफ ऑल द टर्म्स, तो वो होमोजीनियस कहलाती है, जिसे अभी पहले डिस्कस करते हैं जनरल फॉर्म ऑफ लीनियर पार्शियल डिफरेंशियल इक्वेशन, एंड देन वी विल से होमोजीनियस, व्हाट इज होमोजीनियस एंड नॉन होमोजीनियस। सो जनरल फॉर्म ऑफ लीनियर पार्शियल डिफरेंशियल इक्वेशन, एंड दिस इज a0, ये कॉन्स्टेंट्स हैं, कोफिशिएंट्स या फंक्शन ऑफ x एंड y हैं। सो पहले nth ऑर्डर टर्म्स लेते हैं। z जो है फंक्शन ऑफ एक्स वाई है, z डिपेंडेंट वेरिएबल है, x एंड y आर इंडिपेंडेंट वेरिएबल्स, प्लस a1 डेल n z अपॉन डेल x n माइनस 1 डेल y, डिनोमिनेटर में n माइनस 1 एंड 1 इज n, एंड सो ऑन, प्लस an डेल n z अपॉन डेल y n। सो ये nth ऑर्डर टर्म्स हैं। नेक्स्ट हम लेते हैं n माइनस 1, सो b0 डेल n माइनस 1 z अपॉन डेल x n माइनस 1 प्लस b1 डेल n माइनस 1 z अपॉन डेल x n माइनस 2 डेल y, एंड सो ऑन, एंड लास्ट टर्म होगी bn माइनस 1। सो सी हियर nth ऑर्डर n माइनस 1 डेल n माइनस 1 z अपॉन डेल y n माइनस 1, n माइनस 1th ऑर्डर टर्म्स हैं। सो इन बिटवीन many will be there, and then we write one order and then zero order terms. So m0 del z upon del x, m0 is constant, and m1 del z upon del y. So here 1 and 1 plus n0 z is equal to fxy. This is one order first order terms, and this is 0th order. So this is equation 1, जहाँ की a0 a1 up to an, b0 b1 up to bn minus 1, then m0, and in between m0 m1 and n0 are constants or functions of x and y. Then equation 1 is called linear partial differential equation with constant coefficient। अब हम इसे शॉर्ट में लिख सकते हैं, डेल अपॉन डेल एक्स इज इक्वल टू डी एंड डेल अपॉन डेल वाई इज इक्वल टू डी डैश। तो ये इक्वेशन हो जाएगी a0 dn प्लस a1 dn माइनस 1 डी डैश प्लस an d dash n, then we can write plus b0 dn minus 1 plus b1 dn minus 2 d dash, and it goes up to bn minus 1 d dash n minus 1. Then last is we write m0 d plus m1 d dash and n0 and common is z, because this is del upon del x and del upon del y, so z will be with each, is equal to fxy. So we mark it equation 2. Further we can write down it in short, that is f d d dash d comma d dash z is equal to, this is function of d and d dash, z is equal to fxy. We mark it equation 3. This is in short form. Now in this equation, equation 2 or 1, if all the terms are of same order and of first degree and not multiplied together, then we call it homogeneous linear partial differential equation with constant coefficients. We have taken linear partial differential equation and that is defined by 1, 2 or 3. All 3 are same, only notation is different. So if order of all terms in linear partial differential equation is same, then the equation is called homogeneous linear partial differential equation with constant coefficient. And if order of all the terms in linear partial differential equation is not same, then the equation is called non-homogeneous linear partial differential equation with constant coefficients. Various methods are to solve homogeneous linear partial differential equation, and general solution has generally complementary function plus particular integral. So various methods we will study and we'll find general solution. So for complementary function, working rule and its alternative. But now we will study all the steps to get a general equation and all the methods also and theorems also related to it. So solution of homogeneous linear partial differential equation with constant coefficient. We have this equation a0 dn plus a1 dn minus 1 d dash plus an d dash n into z is equal to fxy. So यहाँ हमने सिर्फ फर्स्ट टर्म लिया है because order is nth order and same for all terms. So now this is homogeneous equation and we mark it 1. a0 a1 an are constants. So इसे अगर हम rewrite करें, so f of d d dash z is equal to fxy, and this term is equal to f d d dash. So first theorem है, if u is the complementary function and z dash a particular integral, जैसे पहले कहा complementary function plus particular integral को ऐड करके हमें जनरल सॉल्यूशन मिलेगा. So u and z dash CF and PI of a linear partial differential equation f d d dash z is equal to fxy, then u plus z dash is a general solution of the equation. So इसका proof करते हैं. ये given है f d d dash z is equal to fxy and complementary function u of 1, most general solution of equation f d d dash z is equal to 0. Right hand side we are taking as 0, you can say. अगर u solution है तो इसको satisfy करेगा. So f d d dash u in place of z it will be u, it is satisfying, is equal to 0. So now we have to note a point that complementary function must contain as many arbitrary constants as is the order of the equation 2. The complementary function was the most general solution, and any solution z dash of equation 1 is called particular integral of 1. So this is any solution. Here we have to note that particular integral does not contain any arbitrary constants. Thus by definition we have f d dash z dash, because this will also satisfy the equation, is equal to fxy. So we add this equation 3, and this is equation 4, means we are adding complementary function and particular integral. So we take common f d dash, and this is u plus z dash is equal to fxy, and it means this is satisfying the equation, and this is the general solution of equation 1. Means this is a, so u plus z dash is a solution of f d dash z dash is equal to fxy. 2 when we had taken right hand side equal to 0. So equation 1 and 2 are of the same order. The general solution u plus z dash will contain as many arbitrary constants as the general solution of 1 requires. Second theorem है, if u1, u2, un are solutions of the homogeneous linear partial differential equation f d dash z is equal to 0, then summation r is equal to 1 to n cr ur is also a solution, where c1, c2, cr, cn are arbitrary constants. Proof is, given equation is f d dash z is equal to 0, and we have cr ur. This is the solution of this. So we have f d dash cr ur is equal to, we can rewrite it, cr जो है constants हैं, so उन्हें बाहर ले लिया, f d dash and ur, एंड मान लीजिए हम कोई एक सेट अनदर लेते हैं वी सेट v1 v2 v3. सो ये एक्सप्रेशन हम लिख सकते हैं दैट f d डैश सिग्मा r इज इक्वल टू 1 to n वी आर इज इक्वल टू, ये समेशन अब पहले ले लें, सिग्मा r इज इक्वल टू 1 to n f d डैश देन वी आर. सो लेट्स से दिस इज 1 2 and 3. So these are true where r is taking values from 1 to n, and this is for any set of functions Vr. This is true. Equation 3 is true. अगर हम इन्हें यूज करें सेकंड एंड थर्ड इक्वेशन को, यूजिंग इक्वेशन 2 and 3 we can write f d dash sigma r is equal to 1 to n c r u r. This is equal to, we can write sigma outside r is equal to 1 to n f d dash c r u r, and then we use second one and we write it c r sigma r is equal to 1 to n f d dash u r. अब जैसे कि हमने माना है कि u r सॉल्यूशन है इक्वेशन 1 का, सो ये सेटिस्फाई करेगा. इट मीन्स एफ डी डैश यू आर इज इक्वल टू 0 एंड आर इज टेकिंग वैल्यूज फ्रॉम 1 to n, एंड इट मीन्स जो अभी हमने एक्सप्रेशन ऑब्टेन किया दैट इज सी आर सिग्मा आर इज इक्वल टू 1 to n एफ डी डैश यू आर. दिस इज 0. Because this is 0, it means it is 0. Then we can go back, and which is that f d dash जहाँ से हमने स्टार्ट किया था इनिशियली n c r u r. दिस इज 0, एंड यही हमें प्रूव करना था कि अगर u r सोल्यूशन है तो c r u r भी एक. दिस शोज एंड प्रूव्स दैट सिग्मा r इज इक्वल टू 1 to n c r u r is also a method for finding CF of homogeneous linear partial differential equation with constant coefficient. इसका हम कॉम्प्लीमेंट्री फंक्शन फाइंड आउट करते हैं. तो जैसे कि हमें इक्वेशन की शॉर्ट फॉर्म हमने डी डैश z इज इक्वल टू एफ एक्स वाई. अगर हम होमोजीनियस लिख रहे हैं तो सिर्फ फर्स्ट टर्म लिखने से nth डिग्री का, दैट गिव्स अस होमोजीनियस. सो वी कैन राइट और a0 dn प्लस a1 dn माइनस 1 d डैश प्लस a2 dn माइनस 2 d डैश स्क्वायर एंड सो ऑन प्लस an d डैश n z इज इक्वल टू एफ एक्स वाई. ये भी लिख सकते हैं. दिस इज होमोजीनियस लीनियर पार्शियल डिफरेंशियल इक्वेशन विद कांस्टेंट कोफिशिएंट्स, क्योंकि हमने यहाँ a0 a1 a2 up to an, these are constant coefficients. So complementary function of equation 1 is the general solution of, जो लेफ्ट हैंड साइड टर्म्स हैं उन्हें इक्वल टू 0 रख देंगे. a0 dn प्लस a1 dn माइनस 1 d डैश प्लस a2 dn माइनस 2 d डैश स्क्वायर एंड अप टू an d डैश z इज इक्वल टू 0. सो फैक्टराइज अगर हम करें सो d माइनस m1 d डैश d माइनस m2 d डैश एंड d माइनस mn d डैश z इज इक्वल टू 0. एंड जहाँ की m1 m2 mn आर सम कॉन्स्टेंट्स. अगर हम इनके सॉल्यूशंस फाइंड आउट कर लें, दैट विल बी सॉल्यूशन ऑफ द इक्वेशन. द सॉल्यूशन ऑफ एनी वन ऑफ द इक्वेशंस is also a solution of equation say 2 and 3. Equation 3, clearly the solution of any one of the equations is, equations कौन सी हैं? Equations d minus m1 d dash z is equal to 0, d minus m2 d dash z is equal to 0, these equations. So that will be solution of equation 3 also. The solution of any one of the equations d minus m1 d dash z is equal to 0, d minus m2 d dash z is equal to 0, etc. is also a solution of equation 3. So अब इसका इक्वेशन का सॉल्यूशन फाइंड आउट करते हैं. तो अब हम देखते हैं d माइनस m जनरल ले लिया, d डैश z m1 m2 mn की जगह जनरल m ले लिया इज इक्वल टू 0. तो इसका जनरल सॉल्यूशन जो है z इज इक्वल टू 5y प्लस mx है. सो लेट्स सी कैसे ये वैल्यू है. इसे हम लिख सकते हैं डेल z अपॉन डेल x माइनस m डेल z अपॉन डेल y इज इक्वल टू 0. So this is equal to p minus m q is equal to 0. एंड अगर इसे लैग्रेंजे इक्वेशन से कंपेयर करें, सो लैग्रेंजे इक्वेशन, और जब इसे कंपेयर करते हैं सो dx अपॉन 1 इज इक्वल टू, सो दीज आर लैग्रेंजेस ऑक्सिलरी इक्वेशन. dx upon 1 is equal to dy upon minus m is equal to dz upon 0. So ये लेग्रेंजे ऑक्सिलरी इक्वेशंस फाइंड आउट कर ली. अब इन्हें हम इंटीग्रेट कर लेंगे दो फ्रैक्शंस लेकर. सो दो फ्रैक्शन हमने ले लिए dy प्लस m dz इज इक्वल टू 0. लास्ट टू फ्रैक्शंस एंड इट इज इंटीग्रेटेड. It is y plus mz is equal to c1 and only third लिया, third fraction, so dz is equal to 0 and it gives integrating z is equal to c2. So this is say 4 and 5. So from 4 and 5 general solution of p minus mq is equal to 0 is z is equal to 5 y प्लस एम एक्स। फर्स्ट टू फ्रैक्शंस लेने पर dy प्लस एम डी एक्स इज इक्वल टू 0 इंटीग्रेट किया तो y प्लस एम एक्स इज इक्वल टू c1, और जब ओनली थर्ड लिया सो dz 0 विच गिव्स z इज इक्वल टू c2। सो इसे हम 4 and 5 मार्क किए एंड 4 and 5 का जनरल सोल्यूशन ऑफ दिस इक्वेशन है z इज इक्वल टू 5 y प्लस एम एक्स, वेयर phi is an arbitrary function. So we assume that the solution of equation 2, when we have kept right hand side as 0, is z is equal to 5y plus mx. We assume that a solution of f d d dash z is equal to 0 when we have kept it 0 is of the form z is equal to 5y plus mx. And if we differentiate it dz, this will be del z upon del x. So this is m phi dash y plus mx, phi dash y plus mx, then mx का हो गया m, then d square z second time, this is d square z upon del x square. So second time करें तो phi double dash y plus mx and m square. Then we do nth time del n z upon del xn. So this is mn phi n y plus mn. And similarly y के रिस्पेक्ट में करें d dash z del z upon del y is equal to phi dash y plus mx into 1. Then we do d dash square z is del square z upon del y square. It is phi double dash y plus mx. And similarly we can go up to d dash n, this is z. Z is equal to dn z upon dyn, which is phi n y plus mx, and we take d to the power r and d dash s. This is equal to, now in general we take dr d dash s z is equal to, this will be del r plus s z upon del xr del y s, which is m to the power r phi to the power r plus s y plus mx. Now we substitute these values in equation 2. Equation 2 is this, when we write it in terms of a only, degree n, so that becomes a0 m to the power n plus a1 m to the power n minus 1 plus a2 m to the power n minus 2 and so on, plus an into phi to the power n y plus mx is equal to 0, and which is true if m is a solution of or root of the equation. Root of the equation, which one? a0 m to the power n plus a1 m to the power n minus 1 plus a2 m to the power n minus 2 up to an is equal to 0. अगर इसका root है, and this equation is called auxiliary equation. It is obtained by putting d is equal to m and d dash is equal to 1 in f d d dash is equal to 0, जहाँ की m1 m2 mn जो है रूट्स हैं इस इक्वेशन के. अगर m1 m2 mn रूट्स हैं तो दो केसेस अराइज होते हैं जिन्हें हम देखते हैं. केस 1 फर्स्ट, then we will see case 2. Once we get the auxiliary equation, we find out its roots, say m1, m2, mn, because n roots are there. Then two cases arise, as we did earlier, that roots are distinct or repeated roots. So two cases arise. One, when m1, m2, mn are distinct, then the part of CF corresponding to m is equal to mr is z is equal to phi r y plus mrx, for r is taking values 1 to up to n. Now the equation whose roots we are taking, that was a0 dn plus a1 dn minus 1 d dash plus a2 dn minus 2 d dash square and so on, plus an d dash n z is equal to 0. This was the equation, and this is a linear equation. It is a linear equation, so sum of solutions is also a solution. It means we can say CF of, say, this equation we have already mentioned. Here we say A, equation A is equal to phi 1 y plus m1x plus phi 2 y plus m2x plus phi n y plus mnx. ये समेशन ऑफ सॉल्यूशंस हो जाएगा, जहाँ की phi 1, phi 2, phi n are the arbitrary functions. Phi's are arbitrary functions. Now case 2, when roots are repeated, इस case में let's say m is repeated root, so we say d minus m d dash into d minus m d dash. This is repeated root, so we have this z is equal to 0, and suppose we put d minus m d dash z is equal to v. So this is d minus m d dash v is equal to 0, or we can say d is what? Derivative del v over del x minus m del v dash upon d dash is with respect to y, so m dv upon del y is equal to 0, and this is Lagrange's form. So we find out Lagrange's auxiliary equation, and that is dx upon 1 is equal to dy upon minus m is equal to dv upon 0. So we take two independent integrals, first two, and this gives minus m dx is equal to dy. So we integrating we get mx plus c is equal to y. And because we had taken C2 earlier in this article, we will write it C3. And when we take this one, last one, integrating, it gives V is equal to C4. So the answer is, solution is V is equal to phi. Said earlier that M is equal to MR. In that case, CF is this much, phi R Y plus MRX. Similarly, here we say phi Y plus MX, the complementary function, and phi is an arbitrary function. Now we can write down value of v in the equation. In this equation we put value of v, so we get d is derivative of, here z is there, del z upon del x minus m del z upon del y is equal to phi y plus mx. This is again a Lagrange form, and we will write the Lagrange's auxiliary equations and then integrate it. So Lagrange's auxiliary equations are dx upon 1 is equal to dy upon minus m is equal to dz upon phi y plus mx. So what happens? We have to integrate. We take these two functions as we did earlier. So y plus mx is equal to c phi. Each time we have different constant of integration. And the last one, we take first and third. This gives dx upon 1 is equal to dz upon phi of c5. So we get dz is equal to phi of c5 dx, and we put minus here and this becomes 0. We integrate, we get z minus x phi of c5. So we get the answer z minus x phi y plus mx and some constant of integration, let's say c6, so it is equal to c6. So general solution of equation d minus md dash into d minus md dash z is equal to 0 is z minus x phi y plus mx, and because there are two, one is this one and another is this, so this gives is equal to psi y plus mx. So we can write z is equal to x phi y plus mx plus psi y plus mx, and where phi and psi are arbitrary functions. So this equation is part of CF corresponding to the 2 times repeated root m. In general, if a root is repeated r times, here m repeated 2 times. If m is repeated r times, then what happens? CF will be phi 1 y plus mx plus x phi 2 y plus mx and x square phi 3 y plus mx up to x to the power r minus 1 into phi r y plus mx. This is CF if one root is repeated r times. Working rule for find complementary function of linear partial differential equation with constant coefficients. So first step है कि जो given equation होगी हम उसे स्टैंडर्ड फॉर्म में लिखते हैं, और स्टैंडर्ड फॉर्म होगा a0 dn, दिस इज इक्वेशन 1. देन सेकंड है रिप्लेस करेंगे d by m एंड d dash by 1 इन द कोफिशिएंट्स ऑफ z. सो ये पूरी टर्म में बिकॉज z इज हेयर, सो d को m से एंड d dash को 1 से रिप्लेस करेंगे. जो इक्वेशन हमें ऑब्टेन होगी उसे हम ऑक्सिलरी इक्वेशन कहेंगे. वी ऑब्टेन ऑक्सिलरी इक्वेशन, शॉर्ट में ए से डिनोट करते हैं, जो चारपिट मेथड में भी हमने यूज किया है फॉर इक्वेशन 1. तो वो जो फॉर्म आ जाएगी वो होगी a0 m to the power n plus a1 m to the power n minus 1 n to 1 and so on plus an, and this is 1 and this is d dash, so this is 1 is equal to 0. If we see this equation, here it is d dash to the power 0 and d dash to the power 0 is what? 1. And in this what happens means d powers are decreasing, n minus 1, next will be n minus 2, and here it is d to the power 0. So if we see, the powers of d are decreasing and d dash are increasing. Powers of d dash are increasing. So this is what m to the power n, because in place of d we have substituted m, so m to the power n, then m to the power n minus 1, and here m to the power 0 which is 1, and 1 is there, so that is 1 because d dash has been replaced by 1, so there is no effect. Whenever d dash is there we have just substituted 1 there. Now in third step we solve this equation 2, solve equation 2 for m, और अगर quadratic equation है तो two cases will arise. First one is all roots are different. M is equal to say m1, m2 and mn. N roots are there and all of them are different. Distinct roots are there. Then we can write complementary function is phi 1 y plus m1x plus phi 2 y plus m2x and so on till we reach to the last value, that is phi n y plus mn x, and where phi 1, phi 2, phi n are arbitrary functions. M is equal to, the same case is going on. Case 1, if M is equal to a1 upon b1, a2 upon b2, and an upon bn, then complementary function will be phi 1, we will put in place of m1 as a1 upon b1, so we will cross multiply, so this becomes b1 y plus a1 x plus phi 2 b2 y plus a2 x, and it goes up to phi n bn y plus an x. इसी केस में अगर हम ये माने कि m is equal to minus a1 upon b1 minus a2 upon b2 minus a3 upon b3 and so on, minus an upon bn, तब कॉम्प्लीमेंट्री फंक्शन होगा phi 1 b1 y minus a1 x plus phi 2 b2 y minus a2 x and so on, phi n bn y minus an x. Case 2 is when m is equal to, let m is equal to m dash, और ये रिपीटेड है, पिछले केस डिस्टिंक्ट थे लेकिन यहाँ पर सेम है, रिपीट हो रहे हैं n टाइम्स, ऑल ऑफ देम आर सेम, तब कॉम्प्लीमेंट्री फंक्शन होगा phi 1 y plus m dash x plus phi 2 y plus m dash x and so on, and it goes up to repeated है, so x will come and in next x square will come x, then phi 3 y plus m dash x, and last में होगा x n minus 1 phi y plus m dash. और अगर इसी में if we take m is equal to a upon b and repeated है, means same root है n times, तब जो corresponding to these n roots तो होंगे ही, complementary function होगा phi 1 by plus ax plus x, phi 2 by plus ax plus x square, phi 3 by plus ax and so on, and last होगा x to the power n minus 1 phi n by plus ax. And if m is equal to minus a upon b, same procedure as we did earlier, CF will be phi 1 by minus ax plus x phi 2 by minus ax and so on till x n minus 1 phi n by minus ax. Then next case will be case 3, when corresponding to a non-repeated factor d on the left hand side of equation 1, अगर एक है नॉन रिपीटेड फैक्टर तो CF जो होगा वो phi y होगा. केस 4, corresponding to a repeated factor dm, d to the power m, on left hand side of equation 1, the part of CF will be because many of them are there. Phi 1y, this is part of CF, because there may be other terms also, other repeated factors are there, because here 2a means 1 is there, and here repeated factors, there may be non-repeated factors also. So part of CF plus x phi 2y, and because this is to the power m, then it will be x to the power m minus 1 phi my. Now we take next case, case 5. In this case we are taking corresponding to a non-repeated factor d dash on left hand side of equation 1. The part of CF will be d dash किससे रिलेट करता है, y से, तो ये phi x होगा. d रिलेट कर रहा था x से, तो ये phi y था, एंड यहाँ d dash y से, तो ये phi x होगा. एंड इसमें रिपीटेड करें तो सेम हमने जैसे phi 1 y एटसेट्रा लिखा था, यहाँ phi 1 x एटसेट्रा हो जाएगा. केस 6, corresponding to a repeated factor d2 on left hand side of 1. The part of CF is taken as, this will be phi 1x plus, now here in place of x it will be y phi 2x, and it will go up to y m minus 1 phi m x. So we have alternative working rule also for finding CF. The value will be same, but let's see how to remember it. Alternative working rule for finding CF. So here we assume given partial differential equation is f d dash, means it's function of d and d dash, z is equal to fxy. फैक्टराइज करेंगे हम इस पोर्शन को, एफ डी डी डैश को, फैक्टराइज इट, into linear factors of the form bd minus ad dash. Then we use the following results. First case, corresponding to each non-repeated factor bd minus ad dash, the part of CF will be taken as phi by plus ax. Second, अगर repeated factor है, corresponding to a repeated factor bd minus ad dash to the power m, the part of CF is taken as, this will be phi 1 by plus ax plus x, because it is repeated, so x phi 2 by plus ax, and it goes up to x m minus 1 phi m by plus ax. Third is corresponding to a non-repeated factor d. Till now it was non-repeated bd minus ad dash, repeated of this, now non-repeated factor d. the part of CF is taken as, because CF is generally is summation of many terms, so this will be one of them, is taken as 5y. Next is corresponding to a repeated factor dm. The part of C is taken as 5 1y plus x 5 2y and so on, x to the power m minus 1 phi m, because it is m, so it is m by my. Next, this is corresponding to a non-repeated factor d dash. Then the part of CF is taken as phi x, and if it is repeated, d dash corresponding to a repeated factor d dash to the power m. The part of CF is taken as phi 1x plus, now y will be there, phi 2x plus y square, phi 3x, and till we reach to, we have last term y m minus 1 phi m. तो ये तो वर्किंग रूल हो गए.